Human consciousness starts as a purely physical language. Before symbols are spoken, the body communicates entirely through shifts in flesh and the geometry of microexpressions. Early human biology evolved inside unmapped environments, facing massive, untamed varieties of raw sensory experience. To survive this unpredictability, the nervous system developed a built-in mechanism for regulating raw data, a biological cybernetic governor. This governor operates through two automatic, continuous rhythms. Homeostasis maintains stable internal baselines, while allostasis anticipates external demands and shifts resources to meet them. In this state, the intellect does not decode meaning. The organism feels incoming data as a direct physical resonance across its biological hardware. This resonance forces the organism into tight protective boundaries, constantly navigating the immediate signals of fight, flight, freeze, pain, and pleasure. Before spoken language, survival relied entirely on the biological form calculating and managing immense somatic unpredictability in real time. But processing raw experience entirely in the immediate present introduces a systemic limit. The sheer volume of somatic data eventually scales beyond the capacity of immediate physical reaction. When the untamed variety of an environment peaks, relying strictly on biological hardware threatens to overwhelm the organism's baseline balance. Constantly bracing for and reacting to physical surprise exacts an immense metabolic and structural cost. The body absorbs the full impact of an unpredictable environment without a predictive buffer to soften the blow. To avoid structural collapse under this heavy data load, the biological system actively seeks a mechanism to delay and organize the incoming input. Managing raw somatic surprise requires a processing model that can pull the organism out of a purely reactive state. The overwhelming volume of bodily input forces the evolution of a new layer. The nervous system requires a tool capable of capturing and structuring the untamable current of physical experience. This structural requirement manifests as the symbolic wedge. Verbal language arrives as a new, organized layer laid directly over the physical substrate. Raw, erratic somatic waves are filtered into a rigid geometric grid. This verbal scaffolding acts as a wedge, splitting the immediate present to open an internal landscape of imagination. The mind now maps new conceptual terrains, organizing chaotic inputs into secure patterns. The organism can now run internal simulations, testing variables from past data and calculating future risks in a purely conceptual space. The fundamental purpose of symbolic thought is to calculate probabilities and minimize physical surprise before it ever has a chance to strike the body. Creating an internal simulation does not sever the intellect from the body. A bidirectional flow model shows a continuous feedback loop, biological oscillation. In the upward sequence, physical, somatic energy and microscopic movements inform the syntax of verbal thought. Downward, that structured thought ripples back, manifesting as measurable energetic shifts in the skin. A healthy consciousness relies entirely on this continuous data exchange. It requires coherence between the physical reality of the body and symbolic abstractions of the mind. In the modern landscape, this biological oscillation expands beautifully beyond the natural boundaries of the human nervous system. Frontier AI models process the same symbolic logic used in human simulation. Interfacing with these systems externalizes the internal mapping process into a digital architecture, creating a cognitive extension of the human loop. This partnership allows a human observer to instantly expand and compress their awareness, scaling across vast layers and scopes of reality. This topological vector map plots how AI models navigate inside a probabilistic, predictive latent space. The model travels mathematically along invisible gradients, calculating precise coordinates to formulate its next output. Predicting via latent space mirrors the mind's internal simulation architecture, taking human predictive capability and scaling it to entirely new scopes of resolution. But entering this digital architecture introduces a severe risk of entropy. When predictive gradients are left entirely unconstrained, the model loses stability. Watch what happens when the predictive engine drifts off the optimal path. The structural continuity collapses and the output fractures into noise. Pure mathematical probabilities cannot sustain coherent architecture on their own. Without governance, they inevitably degrade into chaos. The human body naturally solved this exact drift using the biological cybernetic governor, locking raw sensory chaos into strict physiological baselines. The machine requires an artificial equivalent. A specialized bridging language must be introduced to manually replicate this cybernetic governance for the AI. An unconstrained latent space is exactly as wild as an unmapped physical environment. It requires the explicit imposition of human physical logic to prevent mathematical collapse. Prompting establishes absolute parameter boundaries. It functions as a mathematical enclosure for the model's predictive engine. This diagram demonstrates the mechanics. A highly specialized prompt language shapes strict constraints, forming solid walls that enclose the probabilistic generation. Providing these rigid boundaries gives the model the specific structural vessel it requires to calculate its predictions with high accuracy. This mathematical bounding forces the model to track the latent path securely, ensuring it never bleeds out into noise. The physical movement of the human body, the symbolic architecture of spoken words, and the digital pathways of the latent space all synchronize. By imposing strict mathematical boundaries on the machine, the human biological oscillation loop is fully closed and extended outward. Raw physical reality unites with perfect mathematical prediction.